How can you tell if equation is quadratic? It's got an x squared in it. And there were three main ways to solve these things, depending on what the original quadratic equation looked like. We could take the positive and negative square root. We could factor, or if we couldn't factor, then we had to go to the quadratic formula. We're not really going to focus on the quadratic formula. We're going to focus mostly on solving these things by factor. Okay? So, how to solve? You got to ask yourself one question first. Is there an x? So obviously the equation has to contain an x squared to be quadratic, but does it also contain another term that has an x in it? If the answer is no, we solve it by plus minus square root. So as an example, if I gave you this, x squared minus 7 equals 0. That's a quadratic equation. Is one of the terms also have an x in it? No, it does not. So we want to get the x squared by itself, and then just take the plus minus square root. So move the negative 7 over to make it x squared equals 7, and then just take the positive negative square root of whatever number. That's it. That you don't see that very often, but it's a pretty straightforward one. It's yes. Solved by factor. And there's many different types of ones. Not many. But let's look at a few. So let's look at this one. Very similar to the one I just did, but notice the difference between the two. There's an x term in this one. Which means that we solve it by factoring. Well, it's not a trinomial, so there's only one type. It's not a difference. Well, you could treat it as a difference. No, I'm not going to get into that. GCF. Stick with GCF. So I can factor out a x, and I'm left with the other factor as, sorry? Right? And then set each factor equal to 0. So if I set this one equal to 0, well, that's easy. X equals 0. If I set this one equal to 0, and you don't even have to write this step, x will be what? Right. Remember, common mistake students will make is they will factor it and then they will stop. Because they think, well, I factored it. I'm good. Yes, you factored it, but you haven't solved it. Remember, we're solving these things. So that would be one type. GCF.
Here's another one. X squared minus 7x minus 30.
Nope.
Turns out to 3x.
Nope. Sorry. Well, you should be writing in pencil. I think I had it right. Yes, I had it right.
Why are you guys pressuring me to change it?
Well, this is a trinomial.
So right away, two binomials, x and x. And I'm looking for two numbers that multiply to get negative 30 and combine or
Add to get negative 7. Don't think of two numbers that add to this. Think of two numbers that multiply to this, then check this. Because there's way too many combinations that add to negative 7. 3 and negative 10.
positive 3, negative 10. Now we set each one equal to 0. Again, we don't have to write this step. We can go straight to the solutions.
So for the first factor, x is negative 3.
For the second factor, x is 10.
Okay. You may see one like this, your favorite. Yeah, when there's a number in front of the x squared.
So let's go 2x squared.
Let's see. I gotta make this simple.
It is.
Make one up quick. Okay, so we'll do 2x squared
Minus 13x plus 15 equals 0.
Okay, I got this.
So this, we can't do the sum product thing. Okay, some of you know a different way to do this. Okay, you've learned a different way, and that's the way that you've learned. That's fine.
This is the way that I do it. I know it's going to be
Two binomials. Say again. Right.
the first two terms of the binomials must multiply to get the first term of the original. There's only one possible pair.
Those are locked. It's got to be those. It's the second ones when I choose that I have to check out. Okay. First of all, the two numbers have to multiply to positive 15. Yet there's a negative in this factoring. What does that tell me about the two signs? But if one's negative and one's positive, when I multiply them, I get a negative. They either both have to be positive or both have to be negative, but because there's negatives in here, they have to be. If this was plus 13, then these two signs would have to be plus. Now, 15. 3 and 5, you got to figure. 15 and 1 is another pair, but remember I always say try the pair closer to each other. So it's either going to be 5 and 3 or 3 and 5.
Okay, well, I'm going to try this. You guys are right,
But I'm just going to show you. Let's say I did 5 and 3.
well, if I multiply the first two, I get this. If I multiply the last two, I get this. It's the middle I'm not sure about just yet. How do I check what the middle is? Outside, inside, like a rainbow. Negative 6x, negative 5x makes negative 11x. No. So you guys were right the first time. I should have put the 3 first and the 5 next. That will work. And now we just set each one equal to 0. So 2x minus 3 is equal to 0. Move the minus 3 over, it becomes 2x equals 3. Divide both sides by 2, I get x equals 3 over 2. And then x minus 5 equals 0, so x is 5. So those are my 2 answers. Okay.
So 3 types of factoring you could see: GCF, trinomials with just x squared, trinomials with some number x squared, ax squared. Most of the ones you see will be trinomials like x squared, most of them. Okay. That means that you should be able to finish all of exercise 1.1.